us is going to be the gram. And we abbreviate a gram as G. Now, years ago, we used to abbreviate it as GM for gram. Chemists, scientists do not do that anymore. Some of the medical people still hang on to that. So please use G here. And of course, in your lab too, you put G's all over the place for that one section. So that's our basic unit. Now, a gram, let's see, just to give you some idea, about a paper clip or the largest size of vitamin C tablet that you can buy. And I think one day, I took this ring, if I can get it off today, I took this off and I asked some of you to guess how much. And I heard numbers, I think 50 grams, 100 grams, 70 grams. Okay, and I weighed it. When we went down to lab, it was 7 point something, 7 grams. So it's really easy to misjudge. So a gram is a pretty small amount. Okay, so 1 gram is about a paper clip. Years ago, there used to be this commercial about raisins, and they said, buy our raisins. They're so big and fat and juicy. Each one weighs a gram. Okay, I had to find out. So I bought some of their brand, and I weighed quite a few of them. They lied. They weighed about a half a gram. So they were lying about it. I don't think that commercial's on anymore, but a half a gram is a raisin. You know, your basic, everyday raisin. So mass, 2. We measure volume. And our basic unit is the liter. And a liter, we abbreviate it with a capital L. Again, that's by convention. You sometimes see it a small l, but I usually use a capital L. And 1 liter is about 1 quart. If you're thinking English system, this is a liter. This holds exactly a liter. When you fill it up, there's a mark here on the neck, so it's been very carefully calibrated to hold exactly 1 liter at room temperature. Because if you read the fine print here, it says 1,000 milliliters, or that's 1 liter. And it says TC, to contain, and it says at 20 degrees Celsius, which means if you had something really hot or really cold, it might not be as accurate. Or if the glass were really hot or really cold, it wouldn't be as accurate. And you want the bottom of the meniscus right on that line. And so 1 liter is about 1 quart. When we're measuring, to go back up here, we're measuring grams, we use our electronic balances, and that's all we've got to measure grams with. But volume, there's a lot of different ways to measure volume. If it's a liquid, we have volumetric flasks, and these things, they come in all different sizes. This one is a 10 mil one. This is a 25 mil one. I've even seen them so small that it'll hold 1 milliliter. Does anybody know how many milliliters in a teaspoon? 4, 5. 5 milliliters in a teaspoon, to give you some idea. So really tiny little ones, small enough you can use them for earrings. And so they come in all sizes. They are calibrated extremely well. They're usually fairly expensive. The drawback is, if you don't want 1 liter, this thing is useless. And if you don't want 10 mils, this is useless. That's why graduated cylinders, although they're not quite as accurate, they're graduated, and so this one will hold a total of 100. And this is the size you'll be using in lab today. But in your drawer, you got a 50, you got a 10, and they even come this big. This is the biggest one I've ever seen. Now, let me ask you a question. Okay, you see how much fluid's there, and that's just colored water. And this is graduated up to here. How many of these do you think will fit into there? How much liquid?
4.
4 of them? 4 of them? 3 of them? Anybody else?
4.
How many?
4 or 5.
Between 4 and 5? I first saw this on the Barney show, you know, the purple dinosaur. But Barney didn't have a graduated cylinder in a volumetric class. Barney had a bowl and a measuring cup. And he was asking the little kids, okay, anybody want to be changing their mind?
Two.
Two.
Wow.
Is that just not amazing?
That is.
Volumes are tough to estimate, really tough. This is a 2 liter. This was a 1 liter, so 2 of these. And some, I think the highest I heard was a 5 spot. I've heard students say as high as 10. It's really misleading. Okay, so graduated cylinders we use for volumes if we're talking liquids. We also use, in 1412, we use burettes, which you saw in the video. And this is just a very expensive calibrated glass tube with a stopcock at the bottom, so when you open it up, some comes out. When you first use a burette, you're going to think some idiot made it, and that could be true, but not for the reason you think. The top, when you have it full, it says 0. And it says 50 mils down here. Okay? Why is it written like that?
That will give you an idea of how much you can put in.
Exactly. You don't care how much is in here, you care how much runs out. And so this is a way to measure how much runs out and not have it upside down and have to subtract all the time. Excellent, excellent. So we have those. And then in lab today we're going to be using pipettes, which is a glorified straw that's been calibrated very carefully. And in your video, remember in the video they said don't use your mouth? Okay, because you want to pull the liquid up in it. Well, when I first started chemistry, we sucked everything up. And when I was working in pathology, even then, we had body fluids. We're sucking it up and then putting our finger over. Okay? And as long as you didn't get distracted, you're fine. But if you got some in your mouth, like one time, I was sucking up hydrochloric acid. Okay, not real concentrated, but concentrated enough. Anyway, somebody says my name, and I get too much, it goes in my mouth. When you sit there, if you run your tongue over your teeth, don't they feel slick? Right? Okay, if you suck, I know from personal experience, if you suck some hydrochloric acid in your mouth, it takes the slick right off. And that stayed off for a week or so. So I'd run my tongue over my teeth and they'd feel like dry pieces of chalk. And then the slick came back. I don't know what the slick is. It's probably thin coats of mucus or something disgusting. Ask your, saliva or whatever. Ask the biology people. We do not use our mouths anymore. We're going to use a bulb. And we have fancy bulbs, fancier than what they had in the video. So there's lots of different ways. Even our glassware, our E-flasks, these are graduated, but they're not accurate at all. They just kind of give you a rough idea. Okay, now, on this E-flask that's in your drawer, it says 250 milliliters. Okay, but it's only calibrated to 225. And even that is not accurate. It just means if you filled it to the tippy top, you could get about 250 into it. So even beakers, everything is graduated. So volumes, masses were kind of limited. We use electronic balance in the story. And then volumes, we have several different ways to do it. And then 3, I think I told you about the service station down in Red Bluff, how they switched their pumps to liters. Didn't last. The metric system's never going to catch on here. Okay, now, 3, what else do we measure? Length. And our basic unit is going to be the meter, and we abbreviate that usually with a small m. And 1 meter is about 1 yard. So here we have, this is 1 meter, so you get an idea of the size of it. Okay, 1 meter. If you turn it over, it has the English system. Now, a yard has how many inches? 36. Okay, so if I look over here for 36 inches, go finger to finger here, that's a yard, so a meter is just a tiny bit more.